Hello, I'm Ryan O'Hara. I'm the Technical Director for Aerospace and Defense at nTopology. And I'm just going to spend a few minutes here talking with you about how we can use nTop to actually generate holes in a CAD-based file. So I have a simple example here whereby I have a part, in this case a mold, full assembly. And what I've done is I've actually selected a subportion of this mold, this one right here. And the idea is that I want to actually find and locate and drill holes on this mold for venting purposes, right? nTop is used quite often, and we'll show how we can unlock this capability for drilling holes in parts, right? And oftentimes we want to automate this process so that it's repeatable, not only on this part, but maybe others as well. And so what we're going to do is I'm going to take this part, and then basically we're going to run through what we call here this custom block, a CB, that allows me to pass in variables and then actually change the values of those variables such that we can actually drill some holes on this object. In this case, I actually want to pass this data to Mastercam as a CSV file. And specifically, I want to pass the XYZ location and the gradient and the drill depth and the drill diameter of all these points. And so this is a great way for us to actually do that. So here we go. In this case, I selected a face to perforate, and it turns out it's all of these faces here. If I isolate, you can see those objects right here. In this case, I'm in this custom block, I'm just passing, in this case, a few points. So I'm going to pass, instead of 25 now, I want 50 points. And then a routine that I'm running, my custom block, which we'll go into detail here, is basically generating points on these faces and then calculating the normal there. And then ultimately, after we render here, it's going to show us the holes and the implicit part. Some of you may ask if this data can be used to actually modify a traditional BREP file, and that is indeed the case. But it's not going to be the main point of this topic here. I'm specifically looking at output for related to CAM data, right? And so, but we actually do have a method to be able to drill these holes and represent those as BREP objects. Okay, so there you can see. So the pattern went from 25 to 50. We'll go into some detail now on how we did that. Okay. I've opened up this example file. Basically, this is the equivalent of a compound block that shows how we automate this workflow. So to do that, we have the mold tool itself. In this case, I've actually selected this center face. Let's see if we can highlight that there. This center face, and I want to drill some holes on this. The key thing is that we would actually hide some of these inputs and make those available in the custom block. You'll see those as attachments to this nTop Live. But I wanted to walk through the process now. So on the center face, I want to actually be able to generate a pattern of holes. In this case, I want about 50 points on that face. I also included some additional features. In this case, I actually have on this center face, I have some surfaces that represent holes here. And I actually want to make sure that my holes stay away from those. So I actually designated a list of faces, in this case, these pink ones here, where I want to actually prevent holes from being drilled a certain distance from this object. In this case, it's going to be 2.5 times the drill diameter. And we'll talk about how we did that right now. So along those lines, what I end up doing is I end up doing a combination of offsetting those surfaces, and we're going to just speed up the rendering here. I basically offset those surfaces at a certain distance, and now when I show the tool, you can see how we're just going to emit, we're going to use these offsets to emit holes from this region outside of these objects. Okay, so along those lines, so we got a point count of 50. In this process, we're going to basically take the mold itself and we're going to create an implicit body of that object. I'll represent that here. It's a little bit rough because of a low resolution on rendering, and we can speed that up in the, or we can make that a little bit finer in the future. And then basically the whole idea here is that we're actually isolating that center face, and let's see, we're taking that face, and now what we're going to do is we're going to do a series of operations to effectively generate random points on a mesh face. And the way we do that is we use this block called random points on mesh. So if I isolate this here, I'm actually going to change this. Actually, what I want to do is I actually want to use the center face, and I'm going to just drag this object here. It's going to re-render, and there we go. So as you can see here, we have the center face, and then we're going to take what potentially could be a series of meshes, and then we're going to merge them together. So no real change there. And then we're just going to generate those random points on that mesh. So if we were actually to update this point count, we would generate a new series of meshes. And if we chose a really fine resolution, maybe we actually put a lot of holes in here. So let's put in like, I don't know, 250 holes. And you can actually see that we have quite a few holes now. And some of those actually may lie, maybe I need to do a little bit more, but some of them may lie close to the surface or this where we set the keep away. So I'll just turn that keep away back on. And you could actually see, toggle this, some of those points are in that keep away zone. And we'll talk about how we can remove those using the implicits that represent the offsets there. So we're generating random points, okay? And then basically all we're then using is our evaluate field gradient. We're basically using the implicit model of the CAD body, in this case the mold, right? So this guy here. And then we're looking at the points on this object, and we're actually making sure that we compute the normal at those points. I will caveat that I did include the step about the keep away. So in the, I think it was 218 or 219, we released the ability to use filtering. In this case, I've set up an object where I can use the points, and then I can select points that are outside, in this case, the implicit or the keep away. And so when I do that, you'll see that we actually reduce the number of points, right? Kind of see here. Turn those points, they're going to be filtered out because those are within my keep away zone. So that's a very handy feature, but we're going to pass those points into our gradient calculation. And now with the gradient, let's see if I can get my map on here. And there we go. You can see now we're able to compute the normal at this face. Now this face is a planar face, and so the normal is not very exciting. It's basically just 0, 1, 0, and that being in the y direction, right? And we can actually interrogate that if we wanted to. We can actually look at the properties here, and then we can actually look at the gradient. So it's very, very, very close to 1 in the y direction, and it seems to vary just a little bit in the x. So, but these values are available from this properties block, right? And so we can just grab those gradients and we can visualize them here with this gradient point map. And then this is where things might get a little bit interesting or advanced, is that we're going to use vector multiplication to basically offset those points from their surfaces. So I'm going to isolate, oops, let's see. We'll go with the mold here, and we'll get those points. So on the, let's see where those lines are. There you go. That's what we want. We want the line segments. So what I ended up doing is I actually ended up offsetting these points by quite a large amount. In this case, I think 1,000, or let's see, what was my offset set to? It is. So this line offset is a value, this is 250 millimeters away from the surface. So I put a healthy dose in here to make sure that if we ever went through the surface that we had plenty of a line segment to basically trim away, right? So that's the idea here. But then I use a line segment, and then basically I create a series of drills associated with these, these line segments. And those line segments, or these drills, are actually it's the drill radius is basically half the drill diameter. So we're just generating a series of cylinders from line segments based on those parts, and then we're actually just doing a Boolean subtract in this scenario so that we can actually visualize that. And it'll take just a second to render here. Actually go to a higher res version. Go high res here. While that's loading though, you'll notice I have a new block, and it's called a point map block. And so I'm generating the points of the face of the gradient. It's very similar to what I showed previously. But then what we're going to do is we're going to actually export data associated with these objects as a text file. And specifically, Mastercam will take in a series of XY points, the gradient, the drill depth, and the drill diameter, and fundamentally our output units, and generate a text file from that object. So I'm actually going to cancel this render here. I'm actually going to make quite a fewer points. So this will go a little faster, and we can see the output. And while we're doing that, I want to show the drill file. So in this case, or the Mastercam file of the drills. So you'll notice here I have XYZ, right? I have the normal value, I have drill depth, and I have the drill diameter. So this is an output file that's automatically generated from these points and is then available for Mastercam, and that can be loaded in directly. Cool. So let's see if that actually did what I wanted here. This is verify our output. And we're going to turn on our line segments as well. Okay, so there's our line segments. Just waiting a little bit on the render here. This is a fairly large part. And, there we go. So now you can see how these drills were generated and actually produce what we want in the actual file. Now that's great, and you say, hey Ryan, I need to do really complex surfaces. So we're going to stick with this example here. And when we do that, what we're going to do is we're select a new set of faces. So if I pull up the original CAD part again, so this guy, right? And now I want to generate maybe some new faces here. So we'll actually render those. I want to generate a series of holes. So now we have a significant amount of curvature over this guy, not just a planar surface, but we have both. And we'll show how nTop can handle this as well. So I'm just going to drag my new faces into here. Actually, I'm going to do it this way. Actually, sorry about that. Remove those contents, now place my block. And so now this operation is going to rerun. And the key here is that all the things associated with this custom block, right, are still relevant. And so we, it looks like everything, let's see, we'll turn our render back on of the mold. It's going to take just a second. But you can see here how we have the points that are generated on the file. And let's pull up that gradient map again. Right, and make it so we can see these guys. And you can see how we've actually now computed the normal along these surfaces. And in this scenario now, if I turn off my original CAD file, we can now see the implicit with the holes inside of it here. So I'll isolate that. And now you can see how those objects. So now that same operation actually pierces all the way through the object here because of our long line segments, and then is completely normal to the surface. Pretty cool that we can be able to do this in nTop. Wanted to show you this workflow. All these files and the process to go through this is all available. I hope you have a great day. Take care.